For our Coulomb's law activity, this is the PHET simulator that we will be using. And we are going to choose the macro scale, and this is how it will appear. Now, again, we will see here the charges that are marks in colors blue and red sometimes. And we change this color by, of course, sliding the charge here. So this is the setting of our charge. So we can change the value of the charge by moving this. Now you'll notice that if the charge goes negative, so Q sub 1 is for this charge. So this is our charge number 1. So if it goes negative, then it changes its color to blue. However, as you make it more and more positive, then the color becomes more and more red. So now our ruler here, we can check the value of our ruler. So this value from 0 to 1 is actually 1 centimeter long. So we can transfer this and be able to determine the distance between our charge. So again, the way we change the value of our charge is by sliding this button here below. And for our activity, you'll notice that in the first table, what we will be needing there is to change the value of the charge Q1 and Q sub 2. Now, the intended goal is actually not to keep on increasing the value of Q sub 1 and Q sub 2 as you move from trial 1 to trial 5. So there are 5 trials there that you are going to enter values to. So you will be increasing the value of your charge. So we'll be able to measure the equivalent force. Now here we'll notice that as we change the value of our charge, there's a corresponding number of newtons that are actually both the same in value. Now likewise, we notice that there's also an arrow that points away from one another, or arrows that will eventually point towards each other whenever we have two oppositely signed charge. So if one is a negative charge and the other one is a positive charge, then you'll notice that the arrow changes its direction. Now, all that we will be recording now, of course, is the value of the charge, the distance here which is in centimeter. So we can literally put the values of our charges here at a specific length. So this is the distance r in between our charge. And then again, you can record now the equivalent number of newtons of the force present. So again, when the arrow points away from one another, then this is a repulsion kind of a force. So what we allowed the table to show is the amount of the force that is now ready to be recorded. So again, you'll have 5 recorded values of F. And again, for the first set of tables, what we will be changing now is the value of Q sub 1 and Q sub 2. So you can change the value from negative 10 microcoulomb all the way to positive 10 microcoulomb. So for the first table, this is the range of values where you can change your table. Now, for table 2, so what is intended there is to keep the charge constant. But this time, what we will be varying is the distance between the charge. So from trial 1 to trial 5, the suggestion is that we are going to increase the distance between the charge. So again, the distance that is given to us here is in centimeter. So if in your table it is recorded in meters, then you have to have a corresponding correct representation of centimeter to make it into a meter value. So just check the value that you are supposed to write in the table that you have, if whether it is in meter or in centimeter. But the value of the ruler here is of course in cm or centimeter. So again, for table 2, what you will have is to increase the distance between our charge. So this is how we have our simulator here. So this is the Coulomb's law simulator. So the other one is, of course, this is what they call the atomic scale, but what you'll be using is the macro scale for this activity. I hope that the use of the table, the use of the simulator is clear now.